Good morning, my dear students. Today we'll study about the quality control tools. Quality control tools are 7 tools are there. There are cause and effect diagrams, Pareto charts, flow charts, check sheet, scatter plots like this. So today we'll study about the Pareto chart and also we'll remember the people who have contributed towards the quality in manufacturing area. They are Dr. J.M. Juran, Deming and Pareto and so many other peoples also contributed to the quality improvements in manufacturing area. Let us know the history of the Pareto chart. The name for this chart comes from the person whose name is Wilfredo Pareto. So this chart contains both bars and the line graph where the individual values are represented. All are in descending order by using the bars, and then the cumulative total is also represented on the graph. So let us know the uses of Pareto chart, where this is also used for breaking the big problem into the small problems, and using this Pareto chart it is very much easier to find out the most significant factors which are affecting the big problems in the industrial area. So it helps in focusing on that small problems. So aim of the chart is that separating the vital few from the trivial many, means in the so many problems are there, so we don't know which problems we have to focus, so those can be separated easily by using the Pareto chart. So that's why the postulates is given to this chart is that 80% of the trouble comes from the 20% of the problems. That's why this chart is also known as 80 to 20 rule. So graph is having both left and right vertical axis. Both are used for representing the data values. So left vertical axis is used for showing the frequency of the occurrence, and then the right axis will be used for showing the cumulative percentage of that data values as a total number of occurrences, or it may contain the total cost, or it may be the total of the particular unit of the measure. So you can see the examples which are showing the exact shape of the Pareto chart, where the bars are in a descending order and then different problems are showing on the x-axis, and then one axis, the left vertical axis, is used for showing the frequency of the variables, and then the right vertical axis showing the percentage of the cumulative percentage of these values. So let us take one of the problems which are normally occurring in the restaurant area. So these are the complaints the restaurant people will receive every time. It may be the food is tasteless, waiting time, like that. So the count is made like this. After that we can use the Pareto chart by calculating like this. The first one, we have to make a cumulative of all these values. 789 plus 621 will be 1410. then 1410 plus 109 will be the 1519. Like this, cumulative has to be done to last value. Next step is to make a cumulative percentage like this. After that, we can all these calculations can be shown on the bar graph. It is looking like this. So where the frequency of the occurrences are these values count are shown on this x-axis, and vertical axis complaints are showing on the x-axis, and then count are showing on the right vertical axis, and cumulative percentage on the right vertical axis. So final graph will be like this. So by solving this problem, what we have found that the Pareto chart shows that 80% of the complaints come from the 20% of the complaint types. That is very much true in this problem also, where it involves overpriced and small portions. These two problems are creating more in the restaurant than all these one. So in these complaints, these 20% will normally occurring more and more and creating a lot of problems in the restaurant area that can be easily found by using the histogram. Even that values can be shown by using the break-even point, where maximum points where it is occur, so that will be the break-even point. So that when segregating this, so this will be the trivial many and this will be the fewer one. So I have used so many references for making this presentation. Thank you.